Hello everyone, welcome to Mathematics with Shahab Yakub. Now let's go over the test solution. This is the first question, have a good look at it. The question is about a four-sided figure. It's a trapezium, it says so. And the coordinates are given as follows. A is given, B is given, C is given. This line and this line, they are perpendicular. BC and AD. BC and AD are parallel to one another. This angle is 90 degrees. CD is parallel to the x-axis. Find by calculation the value of H. Hence find the coordinates of D. Now the concept over here is, since we have these 2 points, we can find the equation, actually the gradient of this line. Do the negative reciprocal thing and we will find the gradient of this as well as the gradient of this, and then we will proceed. So now let's look at the solution. First of all, we have B, we have A, we know that the gradient is negative. This is change in y over change in x, 2 over 4, that is half with a negative sign. Therefore, gradient of BC, or for that matter, gradient of AD should be positive 2. If I am interested in equation of BC, so what I'll do, I'll plug in the y-intercept, I have the gradient, and this is y is equals to mx plus c. Now C lies on BC. This point is also part and parcel of this line. That means if this is the x coordinate, plug it in over here. This is the y coordinate that goes over here. Hence you find the value of h. So h comma 3h, that becomes 2 comma 3 into 2, which is 6. So the coordinates of C is 2 comma 6. Let me highlight it. And then it further says that this line over here, that is parallel to the x-axis. That means this line is of the form y is equals to a constant. In this case, that constant is this thing, because all along the line the y coordinate do not change. We know that h is 2, therefore 3h is 6, therefore y is equals to 6. That's the equation of this line. So equation of CD, y is equals to 6. What about equation of AD? In order to find equation of AD, now we have the x-intercept. We have the gradient of BC, which is the same thing as this. This time I'm using the other format, that is y minus y1 is equals to mx minus x1. That's the equation of AD. If I solve CD and AD simultaneously, that is the common alphabet, that is D. So I find the coordinates of D, which is 7 comma 6. So 3 plus 3, that is 6 marks for question number 1. So that was a easy type of a question. Not very easy, but still it was moderate. So now over here, this is the second question. There is a point A, there is a point B, they lie on the curve. Show that the equation of the perpendicular bisector of AB is this. So now the first part has nothing to do with this equation of the curve. It has everything to do with finding the gradient of AB, do the negative reciprocal, finding the midpoint, and so on for 4 marks. The second one, the perpendicular bisector of AB meet the curve at C and D. This is simultaneous equation. Once you do the simultaneous equation, then you have to use the distance formula to find CD. You have to leave the answer in the third form. Let's look at the working. Question number 2. This is on the first page. A is 1, 1, B is 5, 9. Gradient, that is positive 2. Midpoint of AB, that is 3, 5. Let me grab my highlighter and let me highlight it. So now we have M, that's the midpoint. We have gradient of AB, that is positive 2. Therefore, gradient of perpendicular, let me write it over here. Therefore, gradient of perpendicular should be negative half. So we use this, we find equation of perpendicular bisector. Actually, it's written right over here. And then this is coming out to be this. So that's how this is done and dusted. So let me just erase this thing from here. The second part, the perpendicular bisector meets the curve. So now this one is about simultaneous equation, in which one equation is linear. So this is the linear equation and this is the non-linear equation. And the rule is make any variable the subject from the linear equation and plug in the non-linear one. So now this thing has 6y equals to such and such. Now my focus is on 6y. Can I write 6y as 3 times 2y? Yes, I can. And 2y is right over here, 13 minus 6. So it's your improvisation, it's your creativity that you bring into use. You expand and then we get this equation and then we apply MTF, that is middle term factorization. So factorization is the heart and soul of algebra. It's the heart and soul of pure math, whether it's pure math P1 or whether it's pure math P3. So now when we solve, we get two values of x. X is negative 1, x is positive 4. Now we have this equation, plug negative 1 over here, we get positive 7. That's one coordinate. Plug 4 over here, we get 4.5. Now it does not specify which one is C, which one is D, so it doesn't make a difference. Now we use the distance formula, we take care of fractions, and this is the answer that we get. So we don't write this thing as root 125 over 2. This is unacceptable. Why? Because they want this format, that is the square root is there and P over Q, they are integers. So second question is also done and dusted. The third one, it says a straight line. Let me first show you this thing. So let me just reposition it. And I think everything else is all good. Now let me first show you the question. It says a straight line cuts the positive x-axis at A, positive y-axis at B. That means the line would be going like this. This angle BAO is pi by 6 radians, where O is the origin. Find the exact value of the x coordinate. A very nice question. A very nice question involving coordinate geometry and the very basic of trigonometry, sine, cos, tan, something like that. So find the equation of the perpendicular bisector of AB. Give your answer in the form the M is given exactly and C is the integer. Exactly means it should be in the third form. So now let's get started. First of all, I drew a diagram. This one is 0, 2. This one I have labeled it as A, 0. It's not given, I have labeled it. And this angle BAO, this is pi by 6. This is the height, this is the base. Therefore, tangent of pi by 6 is height over base. The base is the x coordinate. So tangent of pi by 6, the unrationalized form is the one that I'm using. 1 over root 3 is 2 over A. A comes out to be 2 root 3. That is the first thing. Now it says equation of perpendicular bisector. So first of all, what is the gradient? The change in y is 2. The change in x is 2 root 3. Therefore, the gradient is negative 1 over root 3. And then the gradient of the perpendicular, because we are interested in the perpendicular bisector. So the gradient of the perpendicular would be positive root 3. Again, let me highlight this. And I'm interested in the midpoint. The midpoint is in the third form. It's the average of the x coordinates, average of the y coordinates. Y minus y1 is equals to mx minus x1. Simplify. Root 3, root 3. This is very important. Root A equals to A. Root 3 equals to 3. A power half into A power half, that is A half plus half, which comes out to be A power 1. So that is the logic over here. And this is what we are getting. M is exact, that is root 3. Y is an integer, that is negative 2. And that is exactly what's given. M is given exactly, C is an integer. So whatever they have written, every single dot, every single word that they use, it makes sense. Let's move on. So question 3 is done. Now question number 4. So this is like a traditional type of a question. I don't think so there is anything special in it. ABC is a semicircle with diameter AC. Center O radius 6. So that is the radius 6, that is the radius 6, OC is the radius 6. The length of the arc AB is 15 centimeter. So therefore I can use 6, I can use 6, I can use this angle, let me call it theta, I can use the arc length, I can find theta. The point x lies on AC and BX is perpendicular to AX. That's given. That means we can use trigonometry, sine, cos, tan, Pythagoras. Find the perimeter of the shaded region. The perimeter of the shaded region should be this XC. The logic is find OX using sine, cos, tan, whichever one is appropriate. From the whole radius, subtract OX, so you will find XC. This we can use using sine. If I'm using this angle, this will be found using sine. This will be found using cos. And what else is there? I'll be needing this particular part. That will be used based upon this radius, this angle, let me call it beta. So that will be the arc length BC. So once you have decided on the strategy, that is what I always focus on. Decide on the strategy. Now this is how I have labeled it very colorfully. Arc length AB is r theta. Theta comes out to be 2.5 radians. This is theta. Now theta plus beta is pi because it lies on a straight line. Therefore beta comes out to be 0.642 radians. This is I've taken in 4 significant figures. This was exact. Therefore this is coming out to be exactly 3 SF. I think it would be a better idea if I use this thing as 5 SF. That would have been better. Now if I use sine beta is Bx over 6. Sine beta is this Bx over 6. Similarly, cos beta would be Ox over 6. So we get sine beta is this thing, therefore Bx is this much. Cos beta is Ox over 6, Ox is this much. So the green one is this thing. That is obtained by sine. The blue one is obtained by cos. And OC is 6 centimeter. That's the radius. The difference between the two is XC. So I have this orange one. What is now left? That is this arc length. So now SBC, it's radius times beta. So let me write a radius over here. So this is again the radius times beta. Radius is 6, beta is this, and we get this. So we have one thing, we have the second thing, we have the third thing, we add it all up, and that is the answer for this particular part. So now let's move on. The last question, and this was a very nice question. The diagram shows a sector CAB. Where is the sector CAB? That is C, that is A, that is B. That means this one, and this one will be the radius. The angle would be like this thing over here. A circle with center O and radius R. Center O and the small radius R lies within the sector. Touches it at D. That means OF is R, OD is R, OE is R. COD is a straight line, whereas COD, that's right over here, that's a straight line. And angle ACD is theta radians. Angle ACD is theta radians. Find CD in terms of R and theta. And does it say anything about tangent or something? It says circle, center O, touches it at D, E, and F. So now that if it touches this, that means this thing is 90 degrees. So basically when they use the word touch, line touches a circle, isn't that the definition of tangent? So therefore this is 90 degrees. Therefore this is 90 degrees. And first of all, they're asking us find CD in terms of R and sine theta. That we will do. And then for the next two parts, they're asking us R is 4, theta is pi by 6. So let me do one thing over here. This thing is pi by 6. This thing is pi by 6. If this thing is pi by 6, therefore this thing is pi by 3. The 60, 30, 90 triangle. Therefore this is also pi by 3. So for part B, for part C, this is what we are going to use. So now let's get started. We need the perimeter, we need the shaded region, and so on. Now first thing first, sine of theta, I'm focusing on which triangle? I'm focusing on the triangle CFO. So focus on triangle CFO. So if I focus on this, sine of theta is this thing, which is R divided by the hypotenuse, which is this green length, which is OC. So R over OC or CO, order does not make a difference. CO is R over sine theta. So now CO is obtained. This thing, small one, this is R, this is R, this is R. So now CO is obtained, that is the green thing. Let me highlight it. So CO is R over sine theta. CO is R over sine theta. And this reddish thing, that is OF is equals to OD is equals to R. So that R is being added. So the first part for 3 marks, that is basic use of right angle triangle. Understanding that this is a 90-degree angle, applying the relevant ratio, which is sine in this case, and not forgetting that this needed to be added separately. So that is the first thing. Now it says R is 4, theta is pi by 6. Find the perimeter of sector CAB. CAB. That means we already have what is CD. So CD is given. If I plug in the value of R and theta, I'll find CD. If I use this angle as pi by 6, this is pi by 6, that is pi by 3. And I can use this radius so I can find this arc length. That is as simple as this. You just have to believe in that strategy. So CD is radius of sector. CD is R over sine theta, that's 4 over sine of pi by 6 plus R, which is 4. 4 over half plus 4, this comes out to be 12 centimeter. So now first of all, let me write over here CD, that is equals to 12 centimeter. The next thing, that is the arc length AB, that is 12 into pi by 6 plus pi by 6, 12 into pi by 3, that comes out to be 4 pi centimeter. That is arc length AB. So now this is arc length AB, that is 4 pi, and there are 2 radii for that sector, which is 12 plus 12, and the final answer is this much, that is 24 plus 4 pi. So without even touching the calculator, you are getting the answer for part B. So part B is done and dusted, and this was part A. The area of the shaded region in terms of pi and root 3. Now for area of the shaded region, find the area of this sector. That goes like this, that is this sector. So radius will be R, angle will be pi by 3 and pi by 3, which is 2 pi by 3. So let me write over here 2 pi by 3, radius is 4. You find the area of the sector, that's one thing, keep it aside. Find the area of this triangle. In order to find the area of the triangle, I have R. And what if I have this height? So this height is FC. So sine, cos, tan, whichever one is relevant, or Pythagoras, find this thing, find the area of triangle, double it, find the area of quadrilateral. From the quadrilateral CFOE, subtract this sector, you will find the area of shaded region. Strategy rules. So now over here, that's the triangle I have taken out. This is CF, this is CF, this is 4, this is pi by 6. Sine of pi by 6, that is 4 divided by this thing, 4 over CO. Let me just check one thing. That is, first of all, this thing, there is sine. If I use, I find CO. No, first of all, I'm finding CO. That is separate. Then if I want, I can use cosine. So cosine of pi by 6 is CF over this thing. So CF over this thing, and I found this. Now someone can ask me this question, can we use tangent directly? The answer is definitely yes. So if I use tangent, and let me use this thing, hold for a second. So I think I just went in 2 steps, I could have done in 1. Tangent of pi by 6, that is 4 divided by CF. Tangent of pi by 6 is 1 over root 3, that is 4 over CF, and therefore CF is 4 root 3 centimeter. Of course, this is shorter, this is sweeter. So this is shorter and sweeter. So now this thing is done. And did I find CF for the triangle? Maybe that is one of the reason, because I also need to find the area of the triangle. So area of CFO, that is this thing, which is 4. That is this thing, which is 4 root 3. And that is also over here. So now this comes out to be 8 root 3 centimeter square. Double it, that's the area of the quadrilateral. So area of quadrilateral is 2 times area of triangle. That is this thing. Area of shaded region. And one other thing. Area of sector. This is 2 pi by 3. Radius is 4. That's the area of sector. So now let me highlight these things. So now this is area of sector, this is area of sector, that is the small one. And what else is there? We have the area of quadrilateral. Let me shade it in green color. So area of quadrilateral, that is over here, that is this thing. So the difference between the two, that is the area of shaded region. So basically this was done in 2 steps, sine and a cos. This is done in 1 step. Of course I would prefer this thing, and for some reason I just went a step extra in this one. So now that's how this thing is done, and that completes this paper, which is about 5 questions. And how many questions were of each? So basically there were 2 questions of circular measure and 3 questions of coordinate geometry. So 3 questions of coordinate geometry, 2 questions of circular measure, and that is a good practice for your upcoming test. Stay tuned for more content on mathematics with Shahab Yaqub.